Okay, hello and welcome to lesson 2.7, where we'll be using graphs to represent the motion of objects. There are two types of graphs we're going to see in this chapter. We have the position versus time graph and the velocity versus time graph. Also, what we're going to be doing with these is we're going to calculate slope and we're going to calculate the area under the graphs. So basically the skills you need to be ready for this lesson are you need to be able to calculate the shapes, calculate the areas of really basic shapes like triangles and rectangles. And that's actually the only two shapes you need to be able to calculate. And you need to be able to calculate slope. So let's drop those down real quick, those equations. You probably have these memorized. Go ahead and write them down as a refresher anyway. This is the equation for slope. So equation for slope would be y2 minus y1 over x2 minus x1. Of course, what that means is you'll have 2 points. Let's box this up. You'll have 2 points. You'll have point number 1. You'll have point number 2. So you've got x1 comma y1, and you'll have x2 comma y2, and the numbers get plugged in as they are here. The two areas, of course, area of a rectangle is base times height, or you could say length times width, or there's just a bunch of ways to say it. Of course, you probably have that memorized. And area of a triangle is 1/2 times base times height. So we're going to apply these 3 skills to these 2 types of graphs. Something to say about the meaning of these is, especially this position versus time graph. It's a little of an abstract concept, but basically it represents, this type of graphs represents where is the object and at what time. So just as an example, don't write this point down, but I just need some sort of reference. Don't write this down. This 2 seconds, comma, 4.5 inches. This point, 2 seconds, comma, 4.5 inches. This would mean that we have an object. Take a look at this tape measure here. That would mean that we're measuring the motion of an object on a stopwatch. And it means that it probably started at 0, 0, but we don't know. But this means that 2 seconds into the journey, the object is located right here. Oh no, excuse me, it'd be over here, 4.5 inches. So if you have another point, you know what, I will use 0, 0 for a second. Don't write this down either, we won't need it, I'm just explaining what it means. A point, so 0 seconds, at 0 seconds, the location is 0 inches on this line. And then 2 seconds later, we have the object all the way over here. It has moved to 4.5 inches. So if you take a bunch of these points and you put them on a graph, you then have a position versus time graph. Velocity versus time graph is a little more complicated because it involves, you'd have to use the like the needle on a car, the needle that represents your speed. So kind of an abstract thing, but we'll get used to what the meaning of it is as we go along. So all we're going to do is we're going to calculate slope of position versus time. We're going to calculate slope of velocity versus time. And for velocity versus time, we're also going to calculate the area underneath that graph. So starting with position versus time. All right. Calculate slope. on the PVT. That stands for position versus time. We're going to do a really basic sketch here. I'm going to make it kind of large because we'll be writing in it. Here's the y-axis. It'll have 15, 30, 45, 60. Also, we have 0 here, of course. 15, 30, 45, and 60. On the x-axis, we'll have corresponding to those 1, 2, 3, and 4. I should have drawn that a little bigger, but that's okay. Okay, so in math class, this would be good enough for us. We would just leave it as is. There would be no labels, but this is physics. We got to have some meaning to these. These numbers need units. So on my x-axis, it's time written in seconds. On my y-axis, it's position written in meters. So here's what you'd be given these. I wouldn't expect you to just decide that it's meters. It could be inches, it could be miles. And here's our points. We've got, well, I don't think I could fit that in there. 4,60. So there's our points that are given in this problem. This is 1,15. This is 2,30. This is 3,45 and 4,60. All right, now it's important to remember that these are not just regular numbers. They actually have units to them. So 3,45 actually means that 3 seconds into the motion, our position is 45 meters. 4 seconds into the motion, our position is 60 meters. You can kind of see each second we're moving 15 meters. So we're starting at, this is 0, 0, and we're moving up from there. We could use 0, 0 for the slope, but we don't always have 0, 0, so I want to demonstrate that we can use a different point for that. So I could pick any of these points. I just got to pick 2. So I'm going to pick these guys, 2, 30, 15, 1, 15. We're going to calculate slope. So it's y2 minus y1. So 30 minus 15. Those are the y values because they come second. Divided by 2, 1. So let's do our slope. And we're going to use our units here. In the future, when you're calculating slope by yourself, I won't have you include the units, but the point of this example is to teach us something. It's a little bit of a trick. So really, it's not just 30 minus 15, it's 30 meters. That's our unit for the y values. So every of these y values has a unit of m. 30 meters minus 15 meters over 2 seconds minus 1 second. We don't need a calculator for this. It'll be 30 minus 15 is 15. So it's 15 meters on top. 2 minus 1 is 1. 1 second on bottom. We could simplify that. Really, it's just 15 over 1, which is 15. But also the important thing, the reason I had my units here, is this. Meters divided by seconds. Meters divided by seconds equals meters per second. So we have 15 meters per second. So you can carry the units along in your calculation if you want, or you can kind of just memorize this. The fact that on a position versus time graph, we're always going to get a unit of meters per second. Basically, on a position versus time graph, we're always going to have velocity. So that's the fact that I want you to memorize here. On a position versus time graph, On a position versus time graph, slope represents velocity. So basically with these problems, what I'm going to do is, on quizzes and tests, I'm going to give you a graph, and I'm just going to say, calculate velocity. Here it says, calculate slope. But what I want you to know is that when I say calculate velocity, I need you to know that that means calculate slope. So on position versus time graph, slope and velocity are the same thing. On a position versus time graph, slope and velocity are the same thing. And for velocity versus time graphs, we'll have something different. We're going to calculate area and slope on this graph, so you might want a fresh page. You might be writing small. Okay. Let's calculate slope and area on the Vvt. Of course, this represents velocity versus time. I'm going to make it a little larger to make my point. 0, let's say 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds. Much better. And of course, that's 0 seconds. All right. I'm going to go by 12s on this one. 12, 24, 36, 48, and 60. Notice I wrote the units in there with them. I can't really fit. These are supposed to be meters per second, but I can't write all those together. So I'll just write it over here. Velocity is meters per second. Time is in seconds. Don't get too erotic trying to get these perfect. You don't need to get your drawing perfect. The main thing is to write down these points that I'm about to write down. So I'm going to actually write the units with the points just to demonstrate that, just to make it a little more clear. So this point right here is 1, 12, but this is physics, man. We've got to have units. 1 second, 12 meters per second. This will be 2 seconds, 24 meters per second. Be careful, that's 24. This one is 3 seconds, 36 meters per second. And this is 4 seconds, 48 meters per second. Finally, 5 seconds, 60 meters per second. Now you might already see what the slope is going to represent, and it's based on what's increasing. It's kind of a hint that we're gaining 12 meters per second of velocity. So our slope, whatever it means, it's the thing that represents changing velocity. Let's go ahead and calculate it real quick. I'm going to use the first 2 points again. You could use 0, 0, but I want to show that you can't always use 0, 0, so I don't want to give people the idea that it'll always work. But go ahead and use it if you prefer, if you know what I'm talking about. So y2 minus 1 will be 24 minus 12. x2 minus x1 will be 2 minus 1. We're going to include our units again. I'll calculate below because we might write stuff here. Right here, I'll do 24 meters per second minus 12 meters per second divided by 2 seconds minus 1 second. All right, that math is pretty easy. The units are going to look weird though. So 24 minus 12 is just 12. 2 minus 1 is 1. Okay, so here's what we have. M equals 12 meters per second That might sound familiar. That is acceleration. So it's 12 meters per second squared. Now, someone might think, I know this is just kind of a cool situation. I really like the way these units divide. I think it's fascinating. So we have meters per second, and of course that's meters per second squared. A lot of people ask, wait, shouldn't those cancel out? And the answer is no. They would cancel out if they looked like this, meters per second times seconds. That's how they would cancel out, because I'm going to arrange that even better. Meters per second times second. They would cancel out like that, because, I mean, there's one on top, one on bottom. So that's how they would cancel out, not in this format. Long story short, I want you to memorize this fact. If you have a velocity versus time graph, the slope is acceleration. On a velocity versus time graph, slope represents acceleration. So let's hold that in contrast to our previous graph. Here's what we wrote down for the last graph. On a position versus time graph, slope represents velocity, but on a velocity versus time graph, slope represents acceleration. So what you should be able to do is take a look at a graph and know what that slope represents. A good quiz question would be, what does slope represent on this graph? So slope on this graph, if I give you a graph that's velocity versus time and I say, what does slope represent? You should know that it represents acceleration. If I give you this type of graph and I say, what's the slope mean? You should know that the slope means velocity. So that's some things to memorize. The key word here, is the name of the graph. So you've got velocity versus time. The slope is acceleration. And a position versus time, slope is velocity. Make a flashcard. Make 3 flashcards. You only need 3. Here's what the third one will be. So we still got to calculate area. This one's pretty easy, I hope. And it's really abstract. It's really cool, actually. We got to get the area under this curve. This is something I reckon you've never done. You've never calculated the area underneath a graph, probably. Maybe some of you calculus kids. But it's a really easy skill. Check it out. We have a triangle shape. You've all calculated the shape of a triangle before. So we're just going to use that skill here. I'm going to shade in the area that we're calculating the area of. So you basically just you take the curve and you shade in the area underneath. We're not going to go any further than this because that's where it stops. Let's look at what are the lengths of these sides. We need to do 1/2 base times height. That's what I wrote at the beginning of this video. Area of a triangle equals 1/2 times base times height. So all we need to do is figure out what's the base of this triangle and what's the height of this triangle. And with units, it's pretty odd. It's pretty strange. So the shaded area goes from here to here. It goes from 0 seconds to 5 seconds. So the length of this base is 5 seconds. A very strange concept, but on the graph, it makes sense. Usually you can't measure the length of a triangle in seconds. That doesn't make sense conceptually, but hey, let's go with it. Let's see what happens. I'm going to 1/2 times 5 seconds. And the height is measured in, let's see, the height goes from 0 meters per second to 60 meters per second. So the length of this side is 60 meters per second. Again, we have a very weird length. You can't measure, I can't take this tape measure can't measure something in miles per hour. I can't go up and measure someone's height and say, oh, you're 60 miles per hour tall. You're 60 meters per second tall. That doesn't make any sense in the physical world, but on a graph, we can do that. So it's 60 meters per second. And I'm going to arrange the meters per second like that. It's the same as doing a slash. Okay, let's pull the numbers together and then we'll look at the units. So it's 1/2 times 5 times 60. I have 150 for that. Yeah, 150. But don't forget about the units. The units are seconds times meters per second. And this is the case, this is the opposite of what we saw before with weird units. We're multiplying a fraction. We're multiplying meters per second times the fraction seconds. Well, let's put a 1 over that. And we can see that there's going to be a cancellation. So the seconds cancel one another out here. So the area of this triangle is 150 meters. Once again, that's weird. That doesn't make any sense. The area of a triangle, area is usually measured in meters squared or inches squared or seconds squared. Oh, not seconds squared. Inches squared, meters squared, centimeters squared. It's always something squared. But on a graph, it's different. Graphs are not the physical world. Graphs are just two values put together on a paper. So we can have them represent whatever that we want, and the area has a special meaning. So this is our third fact to memorize. That is, well, what type of graph is this? It's a velocity versus time graph. And we calculated area, which yielded meters displacement. On this type of graph, on a velocity versus time graph, area represents displacement. On the velocity versus time graph, area represents displacement. You have to memorize this as well. This is our third fact to memorize, or just make a great note of it in your notes. Tests are going to be open note this year, so be wise. Get your stuff organized. So basically what you need to do with this information I've given you, you need to apply this to graphs. If I give you a graph and I say, if I give you a velocity versus time graph and I say calculate displacement, you need to know that you're supposed to calculate area. I won't say calculate the area. No, I'll say calculate displacement, and you'll have to know that means area. And this is a very special concept in physics. It's very important, and unfortunately, we won't see it a lot. But the idea in physics is that slope on every graph, the slope has some special meaning. On every graph, area has some special meaning. Now that I mention it, I don't know what the area means on a position versus time graph, but maybe y'all can come up with something. Yeah, I don't have a special meaning for it, but it generally has some special meaning, but you have to think it through. We're just using our simple ones. So make sure you got those 3 facts. I'll put them all right here. These are the guys. This is the whole point of the lesson today. These 3 facts, not the whole calculation with all the units. We're just proving something there. And I'm making a mess on the paper here, but these are the 3 facts. I want you to memorize all 3 of these. And we're going to apply these to some examples later this week. If you have questions, let me know. Shoot me an email. And thanks for watching. Talk to y'all soon.